Alright, what's happening, geometry peeps? Now, today we're going to talk about similar triangles with angle, side, and side angle, side. So, you hear those dreaded words and you think congruent triangles. Well, we can also use them with similarity, and there's a few theorems we're going to go through, and we're going to practice some examples and how to show that triangles are similar using these different methods. Now, the first method is angle theorem. Now, the angle theorem says if two angles in one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, now be careful. You see congruent, you think congruent, but we're talking similarity. We're talking similar. Alright, so let's call this CAT and DOG. Now, if I told you this is 90, and this is 90, and this angle here is 50 degrees, and this angle here is 50 degrees. Now let's think about this. To find this missing angle here, I would take 180 minus 90 minus 50, okay, and that would give me 40 to get 180. Okay, then 180 minus 90 minus 50, well, if I'm subtracting the same two numbers, I'm going to get the same result. Alright, and that's why this is called angle, because if two angles match, by default, the third angle is always going to match, and that's why we don't call it angle. Not necessary. So if two angles in one triangle are the same as two angles in the other triangle, then all three angles match, and then we know our triangles are similar. Now remember, the sides are divided proportionally, so they're the same shape, different size, but same shape nonetheless. So let's go into here and let's say we'll call this A, B, I'm going to go C up top here, C, D, E. Alright? And I'm going to tell you these lines are parallel here and here. So if I have parallel lines, then I know I have corresponding angles congruent. So now I have an angle similarity. Now you have to be careful how you look at this. Alright? If we have the angle of the little triangle, so I'm looking at triangle CED, and the big triangle, and that's CAB. Alright, we have B and E matching up, and then D and A matching up. So the little triangle is similar to the larger triangle. So now let's put some numbers to this and see if we can't solve. It says DA is 2, CA is 8, so that means this whole thing is 8, and CE is 3, and it wants me to find CB. Now, if you can decipher the information from the overlapping triangles, awesome. If you can't, sometimes it's good to redraw them and then label your parts, so we know. We need to know what CD is. Well, if the whole thing is 8, and this piece is 2, this piece is 6, okay, and we know CE is 3 from here. CB is X, that's what we're trying to find. And AC we know is 8. And again, we got 8 minus 2 to get 6 there. So when we set up my proportion, I have 6 is to 8, little is to big, as little is to big. So I get 6x equals 8, 16, 24. So x is 4. And it wanted me to find CB, and that's what I did. X was 4, CB was 4. Alright, so that's how we apply angle similarity to solve the problems. Now, this is the one that can get to us a little. Side theorem. Now, if the measure of a corresponding sides of three triangles are, keyword is proportional, then the triangles are similar. So we got to get this idea of congruence out of our head for this lesson, because we see side, and automatically we think congruence. But now we're talking about proportional relationships. So let's say this is 2, 4, 8, and this is 3, 6, 12. So if I say triangle ABC is similar to triangle DEF, I would have to show that these proportions are equal. So AB and DE match up, so 2 is to 3, as AC and DF match up, as 4 is to 6, as our last remaining piece, 8:12. If these are all equal proportions, then we're good to go. If they're not, then you're not similar. So if you reduce each, 2 to 2/3 is the same. 4:6, that reduces to 2/3. And 8:12, divide by 4, that equals to 2/3. So all three sides are proportional. All right, and that's the key part. They're growing or shrinking, enlargement or reduction at the same rate. All right. Same with side angle side. If two sides of one triangle are proportional, I can't harp that enough, to two sides of another triangle, and their included angle are congruent, then the triangles are similar. So the included angle, so let's this time go 2 to 4, 3 to 6, and I'm going to put that included angle. So again, we have a side angle side relationship, but you need to check if the sides are proportionally equal. So is 2/4 the same as 3/6? And they both reduce to 1/2. And my included angle between the two. So same idea as congruency, except for now we're talking proportional. Proportional. All right. So we got a few more examples, and we're done. All right, so I'm going to fill in the information here. Let's call this 10:12 with a 45-degree angle. And this is 5 and 6 with the 45-degree angle. And I'm going to ask you this question. Are these two triangles similar? And if so, by what method? All right, so we got to look at this. We think it's a side angle side method. Side angle side. Okay, again, there's nothing to match up, so we got to figure this out. So we got to say, is 10 to 5 equal to 12 to 6? And this reduces to 2 over 1, 2 over 1. So yes, they're similar by side angle side similarity. All right, so that little squiggle means similarity there. See, not so bad. Let's try another one. Let's go 8, 2, bam. 4, 16, bam. Are these two triangles similar? Yes or no? If yes, by which method? All right, so let's go in. Now we could test them, but wait a second here. This isn't making sense. I have a angle, and then I have two sides. Here's my two sides. This would be my included angle. This would be my included angle. So already it's not worth testing my proportionals, because I'm going to say no, they're not similar, because the angle is not included. The angle is not included. All right, two more, then I'm done. Okay, so we're going to go, I'm going to tell you these lines are parallel, and that's it. So, are these two triangles similar? So is this top triangle similar to this bottom triangle? If yes, explain why. And now look, I have two parallel lines in a transversal, so I have alternate interior angles congruent here, and alternate interior angles congruent here, and you still have vertical angles here, so really you have all three. So we could say, yes, these two are congruent by angle similarity. So you have to be able to take that information and decide whether you are or not. Okay, last one. 18, 24, 16, 27. Now these are the tricky ones. Alright, so we know we have vertical angles, so we got this angle, so we have a side angle side to the triangle on the left and the triangle on the right. The tricky part with these bow tie-ish problems is who matches up with who. So you have to test. So let's go top with top. So does 18 over 24 equal 16 over 27? Well, this reduces to 3 over 4, and this reduces to 16 over 27. It doesn't reduce. Those two are not equal. So you would be quick to think to say, hey, whoa, back up. These aren't similar. But you got to be careful. What if I test top with bottom, left to right, so here with here? Is that equal to here with here? And 18 over 27 reduces to 2/3, and 16 over 24 reduces to 2/3. So yes, they do match here. So we could say, yes, they're similar by side angle side similarity. So you have to be very careful because you have to test both possibilities. All right, that's all I got. Exactly 10 minutes. Bye.